Hi, my name is Ramiro Mendoza. Today I'm going to be showing you different methods that I used to find the volume for my cross-sectional function. So here is my model. I used two parabolas. Um, to, and I used isosceles triangles to find out what the depth was. And the two functions that I used was y equals negative x squared plus 3x and y equals x squared minus 5x. So yeah. Alright, so one method that I used was the Google spreadsheet. So basically we had to plug in for the first column our lowest bound for mine, which in this case was 0. And the way I increased it was by my thickness. So my thickness was 0.2, and then I lowered that all the way down to number 4, to the value of 4, which was my upper bound. And basically all of this is what I'm going to be finding out for my cross-sectional function. So for the second column I used my upper function, which was negative x squared plus 3x, and for the second column I used my lower function, which was x squared minus 5x, and I took the difference between those two, so I subtracted them, and for my fourth column, which was where the difference was, which was negative 2x squared plus 8x, and then for the fourth column I basically plugged that in to my area function, and then came up with these results. And then for the sixth column, as I mentioned earlier, was my thickness, and then I multiplied the thickness and the area of the triangle and came up with these values for the spreadsheet. Well, the volume that I got was 34.13312, and the volume that I got when I calculated it doing calculus was 34.125, which is pretty much identical values for what I got for the approximated value. Alright, so another method that I used was doing the calculus by hand. So I subtracted my two functions by each other, and I came up with negative 2x squared plus 8x, which I then had to plug into my area equation, which is h squared all over 4. So right here shows where I plugged it in. So we're left with negative 2x squared plus 8x all to the power of 2 all over 4. So yeah, that becomes our volume equation. The way I kind of simplified it here was I broke down this bracket and I made it into 2, and then I multiplied the times. I multiplied the 4 and I made it 1 over 4. And I put it on the outside of the integral. And then, so yeah, my bounds were from 0 to 4. And then I multiplied my area right here, and I came up with negative 4x to the power of 4 minus 16x to the power of 3 minus another 16x to the power of 3 plus 64x squared. So I came up with that. And then when I simplified that more, I got to negative 4x squared, x to the power of 4, minus 32x cubed plus 64x squared. And that essentially became, kind of like the simplified area version. And so yeah, and then when I kept simplifying it, I took the definite integrals of it, and I plugged in the 4, and when I plugged in the 0, I basically got 0. So right here, when I took the integral of it, I got negative 4x to the power of 5 over 5 minus 8x to the power of 4 plus 64x cubed all over 3. And so here is our bounds from 0 to 4. And then I then plugged in the 4 into this equation and simplified that, and then at the very end multiplied it by my 1/4. I did not multiply it earlier because it is a constant, and I can just multiply that later. So when I did multiply it, I got 34.125 units cubed. Alright, so one of the first questions that I used to reflect said, which method do you think was easier for calculating the volume using Google Docs Google Docs spreadsheet, or using calculus? And then it says, use relevant details and examples to fully develop your explanation, acknowledge the limitations, trade-offs of either approximation. I think doing the actual calculus by hand really helped me because it really helps you see how, like, say if you messed up on a certain step, you know which step it is that you messed up on, so that way you can come back and fix those calculations. And then on the other hand, Google Docs for like the spreadsheet, really you really never know how accurate you are, because say if you also type in, because there's many keys that you have to type in, so that it can lead you to your final volume approximation. So you never know, if you press a key that was the wrong one, it could just mess up the entire thing, and you wouldn't know where to go back to fix that actual problem. So yeah, there's I think for this one would be using calculus, like it's on my own by hand, because I can see where it is that I messed up on. Alright, and then another question said, which method gave you a more accurate approximation of your model? So I think, again, using the actual calculus really helped me get a more accurate approximation, because I used a calculator, and I typed in the numbers that I wanted, and it didn't give me a whole bunch of decimals after. So it didn't give me a whole bunch of decimals. It just gave me what I wanted to know, and not a whole bunch of other things. So yeah, I think the one that was most accurate for me was using the calculus by hand. So yeah.